So we'll go through this first thing kind of quickly. I just want to make sure that we're kind of on the same page about how we do these transformations. So does this sound familiar to you? When we do things that are in the vertical direction, that would be like these first five. I didn't spell that right, did I? Vertical. In the vertical direction, those are things that happen on the outside of our function. Does that sound familiar to you? There are things that are done to the function as a whole, and those are going to be things that affect y coordinates. Where when we talk about things in the horizontal direction, those things happen inside of the function. And in this case, and this is key, I don't know if you thought about it this way last year or not, but I want you to start thinking about it this way now. Anything that's happening horizontally, you're doing something to the x, but you're actually pulling x out of the function, doing something to it, and then substituting that thing back in place of the x. And we'll see several examples of that. If I can get you to think about that, then the tricky part of this is what has to do with what order you do transformations in, and that can get really confusing. If you can remember what I just said, that's going to get you over that hump, okay? When we do anything inside of the function or horizontal move, we're going to actually pull x out of the function, we'll do something to that x, and we'll put it back in its place. Horizontal things would only affect x coordinates. So let's go through here. So if I've got y equals x cubed, I'm just going to leave it as, I'm not going to write the y equals part. Shift up by 2. So we would be taking the whole function and adding 2 to it. Did you have x cubed plus 2 for that one? And it would be the same for all of these, right? Root x plus 2, 1 over x plus 2, absolute value of x plus 2. We're taking whatever the function is, the entire function, we're adding 2 to it. All right, shift down by 5. This is going to happen outside of the function or to the whole function. So we'll take our function x cubed and we'll subtract 5. So let's fill out the rest of that row. So shifting up and down are the simplest things, in my opinion, that you can do to functions because you just add or subtract from the whole function. We accomplish the rest of the transformation, stretches and shrinks and reflections by multiplication, right? So if I'm going to do a vertical stretch by 3, I'm going to take my whole function, which was x cubed, and I'm going to multiply it by whatever I'm stretching by, which in this case is 3. So 3 times the whole function. If I were dealing with a square root function, I would multiply the whole thing times 3. Reciprocal function 3 times 1 over x. I would probably write that as 3 over x. Absolute value of x times 3. Vertical shrinks work the same way as vertical stretches, except with a shrink, we'll be multiplying by a number that's less than 1. Stretch will be a number greater than 1, shrinks will be less than 1. So we've got shrink by 1/4, so we'll just take our x cubed function, multiply the whole function by 1/4. Square root of x gets multiplied by 1/4. 1 over x gets multiplied by 1/4. I would probably end up writing that as 1 over 4x. And a vertical reflection, which would end up reflecting it over the x-axis, right? If we're moving a point vertically, we would be flipping it over the x-axis. We accomplish that just by multiplying the entire function by -1. So x cubed times -1 would just be negative x cubed. We feeling okay so far? I started with vertical first because vertical is straightforward. Horizontal, everything's kind of backwards from what you'd expect. Do you guys remember that from last year? Plus moves it to the left and minus moves it to the right. Remember that? Multiplying by a big number actually shrinks it. Multiplying by a really small number actually grows it, stretches it. Everything's kind of backwards. So reflect over the y-axis is the same thing, but pay attention to this, okay? When we do anything in the horizontal, I want you to get in the habit of we are going to pull the x out. So it was x cubed. Now it's just a blank cubed. We're going to do whatever we're going to do to the x. And in this case, we're going to multiply it by -1. So that's going to give us negative x, and then we put it back in. We pull the x out to do something to it, and then we put it back in. So if I'm talking about a square root function, here's my square root function. I pulled out the x. I'll multiply in my head. The x is multiplied by -1. I put it back in. Here's my reciprocal function, 1 over x. I pull the x out. I'll replace it with negative x. I would probably clean that up and call that -1 over x. Absolute value, I removed the x. I replaced it with negative x. Hey, I got a question for you. When I reflect, if I took a graph and I reflected over the x-axis, is that going to be exactly the same as if I were to reflect that graph over the y-axis? Never? Sometimes yes, sometimes no. Give me an example of a type of function where it is the same if you reflect over the x versus the y. We've got one right in front of us, right? When we reflected it over the x-axis, we got the same answer as when we did it over the y-axis. So some of these functions behave kind of strange. The reciprocal function in particular is kind of strange when it comes to comparing horizontal versus vertical things. All right, horizontal stretch by 3. This is where this gets especially confusing for me. Let's go ahead for a cubic function and pull our x out. So I'm leaving those parentheses there. We're going to multiply that x times something. If we want to stretch by 3, what should I multiply the x by? The reciprocal of 3 is 1/3, so we would go 1/3 x that we'll replace in there. Okay, so our square root function, pull the x out, multiply it by 1/3, put it back in. Our reciprocal function, pull the x out, multiply it by 1/3, put it back in. Definitely want to clean that up. That is 3 over x, isn't it? Were you guys comfortable going from 1 over 1/3 x to 3 over x? Dividing by the reciprocal is the same thing as multiplying. Or you could think of multiplying by a fancy version of 1, 3 over 3. That would cancel out the 1/3 down here and we get a 3 on the top, right? Cool. And then, sorry, absolute value function, pull out the x, replace it with 1/3 x. Okay. So that was backwards. Shrinks are also going to be backwards. So let's pull our x out. What are we going to do with our x this time? We're going to multiply it by what? By the reciprocal of 1/4, which would be 4. So it's actually going to shrink it by multiplying it by a bigger number. This one's kind of wacky to me. Look at the reciprocal function for a horizontal shrink by 1/4 and a vertical shrink by 1/4. They're the same, aren't they? How is that possible? You're saying that if I take this function, I squish it by 1/4, it doesn't matter whether I squish it horizontally or vertically, I'm going to get the same answer either way. What? That's kind of weird, but it's true. All right, horizontal shift. So this is backwards also. If we're going to go to the right by 2, when I pull out my x, what am I going to do to that x? To go to the right, we're going to subtract. So x minus 2 is what's going to go back in place of the x. X minus 2 in place of the x. All right, and then to shift to the left, instead of doing a minus, we do a plus. So here's my cubic function. I've pulled out my x. In my head, I'm taking that x, doing plus 5, and putting it back in place of the x. So far, is this seeming kind of pretty reviewish? Yeah. All right. So be honest with you here, this is where it starts to get tricky, is when we start combining some different transformations together. And I'm guessing I've not taught algebra 2 here. So I don't know this for a fact, but I'm guessing that this probably usually doesn't get that much attention in algebra 2, the order. Okay. Did you guys talk about the order and how order is important? No. Let me give you an example, because this caused a lot of confusion last period. I just want you to pay attention for a second, okay? Don't worry about writing this down. Just pay attention, okay? Put the pencils down, relax. All right. Yes, not that relaxed. Pay attention. All right, so check it out. I'm gonna do a vertical stretch by 2, and then I'm gonna do a shift up by 5. Okay, and I'm gonna start with my x squared function. Okay, so if I do the vertical stretch by 2 first, what am I gonna do to my x squared? I'm going to take the entire function and I'm going to multiply it by 2. And I'm going to get 2x squared. And then if I do the shift onto that, I'm going to take that entire function and I'm going to add 5 onto the end. All right, here's where it gets interesting. If I switch it, if I do my shift up by 5 first, and then my vertical stretch by 2, starting with x squared again. So I'm going to take my entire function, which is now just x squared, and what am I going to do to it? Plus 5. Now, when I go to do my vertical stretch, I need to take the entire function and multiply it by 2. Are those the same thing? They are not the same thing. So if I switch the order, something different's going to happen. So we're going to have to think about the order that we do stuff when we're trying to put these transformations together. So our next example is giving us an equation, and we can see that we have several transformations happening. We're going to have to be very careful about what order we do our transformations in so that we can land at this equation, okay? And we're going to use pencil on this because we're going to purposely make some mistakes, all right? Maybe not on purpose. But if you guys don't make the mistakes, I'm going to force us to make some mistakes because I want to show us how we can recover from them, okay? So we're using pencil. You guys all got pencil? I'm switching over to pencil. Now, I'll just say this up front because this came up a lot in my first class today. A lot of you are going to want a nice cookie cutter answer for how do I know what order to do these in? And you're going to be very disappointed in me today because I'm not going to give you that answer, okay? There is an answer. Like if you're looking for an algorithm for what order to do it in, it's just really complicated, okay? What I'll tell you is if you understand a couple really basic things, you'll be able to figure it out. You might have to erase a step though at some point, okay? So I'm going to show you how this is going to work. The two important things I want you to keep in mind are this. When we do something vertically, we have to do it to the entire function. Keep that in mind, to the entire function, everything that's there. And when we do something horizontally, we only do it to the x. We pull the x out, we do something to it and then put that back into the function that was there. So let's do this. So I'll show you how you would do this if you were doing this as a homework problem. We're going to start with our most basic function, y equals, what's our parent function for this thing? Absolute value of x. And we're just going to label off the side, this is our original parent. And then we're going to do steps to it. So we're going to try and make our equation look like this. And we're going to do this one step at a time. So what would you guys like to deal with? We've got a negative on the inside. We've got a 2 multiplying on the inside. We've got a 6 on the inside. We got that 5 on the outside. Which one should we deal with first? We want to do the 2 first. Okay. So we're gonna try the 2 first. So we'll put the 2. Now this is happening inside the function, right? So what we're actually doing is we are pulling the x out, and we're putting a 2 onto it and putting it back into the function. So we end up with 2x here. Now what do we do? We need to describe this. We multiplied the x by 2. That's horizontal shrink by 2. So write that down. Horizontal shrink by 1/2. I've had a lot of students in the past miss points on tests because they leave out the horizontal part. You gotta tell me with stretches and shrinks and reflections what direction you're going in, okay? Shifts, you can just do an arrow. You don't have to say whether it's a vertical shrink or a horizontal shrink. I'll be able to tell by your arrow. But for stretches and shrinks, we gotta do this. Horizontal shrink by 1/2. Awesome. What should we do next? You wanna take care of the negative next? Okay. Now, this is happening inside the function. Pay attention here. Don't miss this. Okay, this is where the confusion happens. You are going to remove the x and only the x. When we do something horizontally, we remove the x. We do something to the x, and then we put the x back in where it was. We're going to stick a negative onto that x, and we'll put it back in here. Now, is that the same thing as if I had written absolute value of negative 2x? It simplifies to that. Yeah, that's fine. Okay. So that worked out. But I want you to get in the habit of writing this way, and it's because it's going to become important. Okay. So this is our reflection over, and this is, I always get confused whether it's over the x or the y. And here's my go-to to get myself unconfused. This is happening inside, agreed? So that means it's going to move points in a horizontal direction. So points are going to be moving side to side. If I have points that are moving side to side, they're going to be flipping over the y-axis, agreed? So this is a reflect over the y-axis. Some of us are starting to see an issue here. Uh-oh, all right. I'm going to say we got 2 shifts left to do. At some point, we are going to have to deal with this +6. Let's go ahead and do this now. So here's my function, y equals, I've got, this is on the inside, -2, and then I'm going to pull out my x, and I'm going to replace it with something. Now, do you see a problem here? That +6 kind of makes me think that I'm going to be shifting to the left by 6. But if I put an x +6 in here, is that going to end up getting me what we want? We're going to distribute that -2 into there. Trouble. Okay, so here's how we get ourselves unstuck. Are you ready? This isn't a big deal because what I'm going to do is I'm just going to modify this equation. Check this out. Wouldn't this equation be the same as -2 parentheses? What could I put inside of that parentheses? X -3, agreed? Now that looks like, that's kind of like what we're going to end up with here, isn't it? And that's the same thing. So we're going to shoot for this equation. It's equivalent to this. It's the exact same equation. So we pulled our x out, and we're going to replace our x, not with an x +6. We're going to replace our x with an x -3. Okay. You guys okay with what we just did there? We just changed the format of our target endpoints, right? Still the same thing, we just changed the format. Okay, so what are we actually doing when we do this? We subtracted 3 from x. Is that left or right? That would be to the right by 3. So this is shift right 3. Now, when I originally looked at this, I thought it was going to be a shift to the left by 6. But the order that we did it in is causing us to have to shift or right by 3 instead. All right, we got one more move to do, and this one should be pretty straightforward, right? We got to get that -5 in there. So that's happening outside. So it's going to happen to the entire function. And that would just be a shift down by 5. All right, so you guys succeeded. You made the mistake, but then we recovered from it, right? Are we feeling okay about that? Now, if we'd been thinking ahead a little bit, could we have avoided having to go back and make that correction? What could we have done differently so that we could have ended up with this version of our target? We could have started by doing the shift first, right? So if we'd started with our shift first, so if we went, I'm not going to write out all the words, but if I'd started with my shift first, I pull out my x and I replace it with x plus 6, right? Then if I'd done my reflection or my stretch, I would just be pulling the x out, the plus 6 would stay, right? And then I could have done the 2x in place of the x there. Do you see how that would end up getting us to the other version of it? So if we were kind of careful about that, if we kind of thought it out ahead of time, we could have avoided having to do this little extra work, but this didn't really take us that much time, right? So if you find yourself, if you're trudging along and you're like, oh, this isn't going to work out, ask yourself the question, could I rewrite my target function so that this is going to work? And if it doesn't, worst case scenario, you're writing in pencil, you got an eraser, back it up a couple steps, try it again, okay? So, guys, how are you feeling about this? You look a little bit more, I feel like I did a little bit better job this period than last period because you guys look a little more confident. The order gets tricky sometimes. The order gets kind of tricky. Okay, this is going to kind of come together as we start graphing these two. So if you've got like burning questions about that example, just hang on to them, maybe jot them down, and we'll come back, circle back around after we've tried graphing. So folks, I'm going to be kind of specific about how I want you to do these graphs. I know I keep doing this to you, and it seems like I'm like a really picky teacher, and I guess I am. But there's a reason, and I like to share the reason. So here's the reason. We're going to be graphing transformations all year long. This is one of our key tools that we're going to be doing, okay? So when we get into chapter 2 and we're dealing with rational functions, we're going to be graphing transformations. And I need you to understand when you do transformations, I need you to understand what's going on in the equation, what's going on in the graph, and what's going on in the points. And the points I'm talking about like a table of points. So I'm going to set forth a style of how we're going to do this in this section, and then we'll revert back to this when we get into chapter 3 and we start graphing logs and exponentials with transformations, okay? So for right now, you're only going to be graphing these parent functions. I did not write the names of them, but I'm hopeful you know the names of all of these. Should we try, what's this first one called? Quadratic or parabola, the second one. It's cubic, this one. Square root, and this is a cube root. We got absolute value and reciprocal. Okay, so when we do this, the reason I put this at the bottom of your page, please don't miss this, is when we're going to tabulate points. And I don't need you to tabulate a lot of points. For most functions, there are 3 points I want you to tabulate. The points with x coordinates of -1, +1, and 0. So for parabola, we're talking about these 3 points. For a cube, we're talking about those 3 points. Those are the key points. If you had those points in the right place, then you should be able to make an accurate graph. You're going to love square roots because we're only going to do 2. cube roots will have these 3 points, -1, 0, and 1. Anybody want to guess for absolute value? -1, 0, and 1. Rational functions, -1 and 1, but not 0. But for rational functions, I would like you to also graph and track the asymptotes as part of your table. X equals 0 and y equals 0. When we get into log functions, there'll be 2 points in one asymptote. Same thing for exponential functions. All right, so let me show you how we're going to do this. Flip this on over. You guys are going to love this. We are going to make, for each step of this, for each transformation, we are going to write an equation. We're going to write in words what we're doing. We're going to make a table, and then we're going to make a graph. Okay, for each step. Now, in your assignment, you're going to do 6 of these, but most of them only have 2 steps. These ones have, how many steps are we going to have here? I see 3 transformations, so we're going to end up making 4 graphs, including the original. 4 tables, 4 graphs, 4 equations. Oh, don't laugh. It's fine. I know it's so much. It's not though. It's not though. So here we go. What's our parent function? Y equals x squared. Write that down. Y equals x squared. Squeeze it over on the left there, because we're gonna have 4 graphs here. We'll start with making a little XY chart. And do we need to have a little whining session and get it out of our system here? Yeah. -0. Yeah. I think you guys will be able to survive this pretty well. This is not huge. Let's see. -1 squared is 1, 0 squared is 0, 1 squared is 1. Leave some space underneath that. When you do this in your assignments, I'm pretty specific on this assignment again. I want to see accurate graphs on graph paper with the points in the right place, not on line paper with little janky looking tick marks all over the place. Get yourself some graph paper and make it look good, okay? There's a whole bunch of it in that drawer over there. Help yourself if you need to take a couple sheets. All right. There's our parent. So let's get this going. Which transformation do you guys want to tackle first? You want to do the +1? The +1 is the only thing happening on the inside of the function, agreed? So that would be safe to do, because if it's the only horizontal thing, you can do it whenever you want. The one that we're going to have to worry about order is the 2 on the outside and the -2. We want to make sure we get those in the correct order because they're both vertical. So I think it's smart to do the +1 first. Let's get that out of the way, and then we can think about the vertical stuff together. So that +1 is going to describe that in words. What's going to happen here? Shift left by 1. And if you want to write horizontal, that's fine, but you don't have to for shifts because I'll be able to tell from your arrow. So our next version of our equation would be y equals, since it's horizontal, we take out the x. We replace it with x + 1. And we'll set up our XY table here. Now, before you start putting stuff in that table, this is pretty important, and it's kind of a key part of our process here. If we are shifting to the left by 1, which column is going to be affected, the X column or the Y column? Left would affect the X column, and what specifically is going to happen to our X values when we shift to the left by 1? So my X values are going to subtract 1. I'm writing X -1. Do you understand what I mean there? You might want to write X coordinates -1. I don't know. But that's just to remind me that I just need to take these things and subtract 1 from each of them. So it'll be -2, -1, and 0. My Y coordinate is going to change at all? Nope. Just copy them down. The Y coordinates are not changing because we're shifting to the left, and that is strictly horizontal. So we'll graph those 3 points, and hopefully we're going to see a parabola that's been shifted to the left by 1. So -2, 1, -1, 0, 0, 1. Oh yeah, look at that. That's perfect. All right. So we're moving into our last two here, and since they're both vertical, we do need to kind of think about how we want to. So what do you think? You want to multiply by 2 first and then do the -2 at the end? Yes? Or do you want to do the -2 first and then multiply by 2 at the end? Why are you shaking your head? No, I see a couple people saying. So this is, since I'm in pen here, I'm going to go ahead and sketch this out real quick on a scratch paper. So I got x plus 1 squared. So if I do my +2 first, that just adds onto the whole thing. And then if I choose to do my ×2 at the end, I got to multiply the entire function times 2. Is that what I want? No, because that's going to end up giving me a +4 at the end, right? So we don't want that. So it should be a minus, you're right. Thank you. But same idea, right? It's going to be a -4 instead of a -2. So can we agree that if we did the multiplication first, we would have 2x plus 1 squared. Okay, I multiplied the entire thing by 2, and then we could do our -2 to the whole thing, and it's not going to be affected by that multiplication. We agreed? So we want to do the multiplication first, the vertical stretch first, and then we'll do the horizontal. I'm sorry, what'd you say? Oh, okay. So we said we were going to do the ×2 first. So, all right, so that would give us y equals 2 times x plus 1 squared. And what are we doing when we multiply the whole thing by 2? It's a stretch by 2, but you got to tell me which direction. Vertical. Vert stretch by 2. I'm okay with you abbreviating a little bit. Let's not go too crazy though. Like VS is maybe a little too much. Vertster by 2. All right. I'm thinking about my coordinates. If I'm stretching vertically, should my x coordinates be changing or my y coordinates? Y coordinates are going to change this time. And what's going to happen to my y coordinates? We'll multiply them all by 2. So y times 2. So my old y coordinates were 1, 0, 1. Multiply those by 2, we get 2, 0, 2. And the x coordinates that we had in our last step, we can just copy them over because they didn't change. We're not doing anything in the horizontal direction. So I'll go ahead and sketch this graph and hope that it looks like it's been stretched vertically by 2. So -2, 2, -1, 0, 0, 2. Oh yeah. Yeah, that looks good. All right, final move here is to get that -2 on there. -2. I keep writing +2. That's stuck in my brain. In words, what are we accomplishing by that -2? Shift down. So ask yourself which coordinates are affected, the x or y. And then modify those coordinates, copy the other ones down, make your graph. Try and do as much of this step as you can on your own. Down by 2 would change my y's. X's stay the same. And there we are. If I had assigned you an even numbered problem for one of these, how could you be confident in your final answer? What could you do? Oh, there you go. Nice. And I'm happy that you've got it out in front of you. That thing, right? You could go and you could graph this equation. You could see if the graph of it looks like that. All right. Okay. So this looks like a lot. Again, most of your problems in your assignments, you're only going to be doing one step, in some cases, 2 steps. So this isn't going to be too much. You're just keeping track of a few points. You're going to get really quick at this as you go. I'm asking you to do a lot here, but it's really going to help you have a deeper understanding of what's going on with our coordinates, our graphs, and our equations. That's going to be super key to your success later on when we start digging into specific types of functions. So you guys willing? It's not like you have a choice, I guess. Well, you do have a choice. You could, it might be too late to switch at this point, but I appreciate you guys. I know I ask a lot and I appreciate your hard work. So what do you think about trying this one on your own?
Sure.
Do you think you could do it? Give it a shot. Hey, before we dive into it, let's talk strategy though. How many different transformations are you seeing?
3.
I see 3. What's this minus on the outside going to do? So that's a vertical reflection over the x-axis. This 1/2 is on the inside. So it's backwards from how you'd think. You would think multiplying by a small number would make it smaller, but it's actually going to stretch it horizontally by a factor of 2. This +1's on the outside, so that's going to shift it up by 1. Now, 2 of these are vertical moves, aren't they? The negative in the front and the +1. You're going to have to think carefully about which one of those you should do first. Okay. You're thinking to do the negative first so that you don't have to multiply the whole thing by -1. So think about it. And if you need to, pull some scratch paper over like we did in the last example and give it a try. Folks, I'm going to work through this quietly up here. You guys work through it. Talk it out with your neighbor. Ask questions. Peek up here if you need a hint, but try and do as much on your own as you can, please. Actually, I'm just going to put my answer up here. Oh, by the way, I should mention this. The one thing I do not need to see when you're doing this, can you guys look up here for a second? I'm sorry to interrupt. Do you see this red stuff where I was doing like x minus 1, y times 2, y? You don't have to do that when you're doing that. That's the one thing that I do not need to see on your work when you're doing it. I did it for the sake of our notes. That's why I put it in a different color, though. It does not need to be in your final work. If it helps you, though, then do it. I'm going to put my solution up here. You guys look it over if you need a hint, but try and do it on your own. And I'll circulate and answer some questions. You guys have been great about asking questions today, and I appreciate that. So the question that keeps coming up is, how do you know what order it is? And again, I kind of warned you that some of you are going to be looking for a nice, clean cookie cutter answer to this, and there just really isn't one. So you kind of got to play around with and think about it. The big one in here is that you have to worry about, basically you need to worry about order whenever you have 2 transformations that are in the same direction, meaning 2 verticals or 2 horizontals. Then the order becomes important. When I look at this problem and I see that 1/2 x, that is the only horizontal transformation. I can do that transformation anytime I want to. It does not matter whether it's first, second, or last. Okay, so if there's only one, you don't have to worry about it. The one that I need to worry about is the negative and the +1, because those are both vertical transformations. We want to make sure that we do those in the correct order to get the answer that we want. So I pull up some scratch paper and I say, let's go ahead and just take care of the 1/2 x first, because we can do it whenever we want. Okay. If I did the negative first, I would put my negative onto here. And then in my next step, I would add 1 to the entire thing. That's going to get me what I want. I think we want to do the negative first. So we're going to do the reflection first and the shift afterwards. If, on the other hand, I had chosen to do the +1 first, then when I do the negative, remember, if it's vertical, you've got to do it to the entire function. So I would end up with negative √1/2 x, but that would change us to a -1, and that's not what we want. right? So you got to kind of think like, okay, there's two of them, so let me try it both ways and see which one's going to work. Just pull out some scratch paper and just mess around with the equation and see, okay, what order do I need to do? And again, remember that the two key pieces of information that we talked about on the front side were when you do anything vertical, you do it to the entire function. When you do anything horizontal, you pull the x out and you replace it with something else. That's where, if you know those two pieces of information and can utilize those properly, that'll get you unstuck on any of those. Okay. Question about the last problem? No, that is not what I said. No, if you have two horizontal transformations, like in this problem that we did just a moment ago, you see how there's two horizontal transformations, actually three here. Then you got to worry about order for those horizontal transformations. But see how there's only one vertical transformation here? If there's only one of a certain direction, you can do it whenever you want. It doesn't matter when I do the -5. I could do it in the first step, the second, third, or fourth step. It doesn't matter. I'm going to get the same answer. It's only when you have multiple transformations in the same direction that you need to think about which one comes first. Okay. Yeah. All right. Let's do this last one. These are the easiest. We saved the easiest ones for last because in these problems, they're going to tell you what order to do them in. Yes. Now, there are some common mistakes that we can make with them, and it's good if we make them because then we learn from them. But these ones they are telling you, this is exact. I copied word for word the instructions out of the book. They're basically saying, do what we did over here, except they're giving you this and you're coming up with the equations instead of the other way around. Okay. So we're just going to start with y equals x to the third. And we'll just kind of write down the steps to the right of it. This is our parent function. And then we're going to do all the steps that they tell us to do. So let's write for our second step, reflects over the x-axis. Now we have to think when I'm reflecting over the x-axis, are my points moving horizontally or vertically? Reflecting over the x-axis would be vertical, right? So this needs to happen to the whole function on the outside. So I'm going to take my entire function, multiply it by -1. I got that step done. Check. What's our next step? Horizontal shrink by a third. Let me write it down. Horizontal means we're going to be doing it just to the x. I'm going to pull my x out of the function. I'm going to do something to it. Now, if I want to shrink it by a third, I'm multiplying it by a big number or a small number? Big number. We're going to do the reciprocal of this. So be careful here. Pull the x out. So we need parentheses to hold its place there. We're going to multiply it by the reciprocal of third, which is 3. So multiply the 3 times the x, put it back in, and we got it. Then we're going to shift it up 5. This is a vertical move, so this is happening to the entire function. So we'll just take our entire function and add 5 to it. These are my favorites because you don't really have to think too hard about them. And our final one is shift left 6. There's a very common mistake that happens with this. This is in the horizontal direction, so we need to pull our x out and replace it. Pull the x out. If you're not putting parentheses in place of that x, you're going to make that common mistake. The x is being multiplied by the 3. When I pull it out, put it back, both the x and the +6 should be multiplied by the 3. I would probably clean this up a little bit and rewrite it as y equals -3x + 18 cubed + 5. Although This is kind of a nice version 2, kind of standard form for a cubic. Either of those would be fine though. I just thought a really good last question on the test type question. I thought of a really good last question on the test type question. What if I gave you this and I asked you this final equation and I asked you to give me 2 different sets of transformations that would get you there? How could we accomplish this differently? And I'm talking specifically about the horizontal shrink and the horizontal shifting. What could we have done instead?
+6 and then times 3 times 3 and then +6.
So we could have done, yeah, so or the other way around, right? So we did our horizontal shrink before our horizontal shift. If we flip that around, if we done our horizontal shift first, we would have, instead of shifting left by 6, we would have shifted to the right by 18. And then afterwards, we could have done the horizontal shrink by 3, and we would have ended up at this equation here. So if you can start asking yourself those questions, that's getting you to a pretty advanced level. If you're kind of just hanging on by a thread here, just keep these 2 things in mind, okay? This is what's going to get you through. When you do something vertically, you have to do it to the entire function, That means if your function already has like a +2 in it, when you multiply, you're going to have to multiply that +2 along with everything else, okay? When you are doing something in the horizontal direction, you have to remember to remove the x, replace it with something. That typically involves putting a parenthesis in there. If you're ever unsure, go ahead and put that parenthesis in there, and then you'll know once you write it in there whether it's necessary or not, whether you can just drop it. All right, what burning questions do you guys have right now? None? Hey, all right, so let me put the assignment up here.